Hi dear student, this is Sanal. Welcome back to AS Level CIE Physics 9702 series. So last session we have discussed about the unit, a standard reference for measurement. If you didn't watch that video, just go and watch that video, understand the concept of unit. Then you watch this video, then you will understand it better. So measurement. Measurement is a process of comparing a reference standard, that is unit, with a given physical quantity. For example, if I am giving you a road I am giving, I'm asking you to measure the length of it. L you want to measure. So what you will do? You will take a meter scale and you will measure this. Let's say you're giving the answer as 20 centimeter. So L is 20 centimeter. That means 20 times you can include 1 centimeter in that measurement. Isn't it so? So in that measurement, can you say that it is 100% accurate measurement? No. Because error may be there, right? Error. Remember the statement. The true value of a physical quantity is always different from the measured value. It can be 21 centimeter, it can be 22 centimeter, 20.1, 20.2 or 19.1 like that. The actual value is different because human error may be there, instrumental error may be there. Because of that, the actual value, the true value of the physical quantity is always different from the measured. There will be a difference between true value and a measured value. Okay, that is called error. So error is the difference between error. How can you calculate? Take the difference between the actual value and the true value and the measured value. True value minus measured value. So error is the difference between true value and the measured value. So this error we will study. So two basic types of errors are there. One is systematic error. And random error. They can ask a 2 mark question related to what is systematic error and random error. The difference between systematic error and random error. Okay, we will understand what is a systematic error. The systematic error happens in one direction only. One direction means what? If this 20 centimeter, you check, okay? If there is a systematic error, the reading may be +1 or -1 or plus 0.5 or minus 0.5. Okay, it will be in either one direction, plus or minus. It is a constant error, okay? So you can say that the systematic error happens in single direction and it is constant. Okay. So what is the effect of systematic error in the measurement? Systematic error. So it leads to a set of measurement which may be higher, all higher value or all lower values because the error is fixed and it is only in one direction. So the effect is what? You are getting a set of readings which may be higher or all lower values. The readings may be all higher or all lower values from the true value of the physical quantity. Okay. True value of the physical quantity. So you understood what is systematic error. It is a constant error, okay? Constant error, it can be plus or minus because it is in single direction. Either it will be high or it will be low for all the readings, all set of readings. Okay, what is the reason, cause? Cause may be because of a faulty instrument. For example, if the instrument is measuring, if you are using a scale, for example, or you are finding the time period of a simple pendulum, you are using a stopwatch. Okay, stopwatch, for example, for complete oscillation, it is taking 2 seconds. Okay, actual value is 2 seconds, but there is an error in the instrument which will show 3. That means what is the actual value? The reading minus that extra error 1, right? Understood. So it can be, the cause can be, what is that? Faulty due to faulty instrument, or any other reason. Can you tell me? Think. One more reason you can say, that is error in the measurement process. If the process, in the measurement process, if there is an error, for example, if you have a scale, you consider a scale. The scale starts from here to here, 0 to 1 centimeter. Okay. Usually what happens, if you want to measure the length, what you will do, you will first one end you will coincide with 0, then you are measuring here, right? Say it's 5, then 5 centimeter you are doing. This is the actual process. If this process, they are measuring it with one end of the scale, then there will be an error, right? Because the 0 starts from here only. This much is missing, right? So that is another possibility, the error in the process. Error in the measuring process. Any other possibility? The third may be due to the experimental design may be wrong. There is a particular error included in during that design of the experiment. So error in experimental design. Okay, these are the possible errors. So examples you can remember, for example, for an instrumental example, if you are taking a tape, okay, if you're using a tape as an instrument to measure length, what happened is, after some time, due to the frequent usage of the instrument, the length of the tape may be elongated. Then what happened, the measured value will be more than the true value, right? That is a fixed value. So you can eliminate this method. If you take the average and take the mean, you cannot eliminate the systematic error. Okay. The only thing is, you need to identify what is the error, and you need to use zero error method to correct it. For example, initially I told you, simple pendulum. That simple pendulum method, if you know 1 centimeter is reading extra means because of the faulty instrument, then you can minus that one and you will get the correct answer. Understood? So it can be corrected, can be by identifying error and use zero error method. Okay, clear? Is a fixed error. It is in one direction, either plus or minus. So this error will be present in all the readings you are taking. So you cannot eliminate this by taking the average. Only thing is, you need to identify the error, calculate the error, and plus or minus it from the final answer. Right? This reason for this error is what? Due to faulty instrument or error in the measuring process or in the design time. Clear? Okay. The next is random error. Okay, random error is a variable error. So previously in the systematic error is goes in only one direction, either in plus or in minus direction, right? But random error, if you check, random error can go plus or minus both direction. Okay, if you're taking a 5 readings, 3 readings may be plus, 2 readings may be minus. So more than the actual value or less than the actual value. Okay, so it is a variable error. So this variable error, what may be the cause of it? Cause is human error, right? Human error is unpredictable. For example, if you're considering the previous example, the oscillation of the pendulum, and you are finding out the time period, then what is the procedure? If you start stopwatch and you will count the oscillation, 10 oscillations you are counting, total time you will take, and you divide it by 10, you will get the answer for time for one complete oscillation, right? So if you are using that experiment, okay, this may be human, because of human error, instead of 10, you are counting only 9. Sometimes you are counting 11. That means it can be plus or minus. So reason, cause, what is that cause? Cause may be due to human error or any other thing. Can you think? Or maybe due to the unpredictable physical condition. If you are measuring the length of a hot rod using a steel scale, what happened? The temperature of the surrounding will change, right? If it is increasing, suppose what happened? The metal scale will elongate, then you will get a reading higher than the actual value. The temperature is reducing, what happened? The scale will shrink, you will get a lower value than the actual value. Correct? So that is also another possibility, another cause for the random error. What is that? Unpredictable physical condition. Unpredictable physical condition. So if you check this one, how can you minimize this random error? You cannot eliminate the complete errors from a measurement. Okay, you can minimize it. So how can you minimize this? To minimize random error, what you need to do? You need to take the multiple readings and take the mean of it. So you can reduce the random error. Take multiple readings and calculate the average. Understood? So now you have learned what is systematic error, what is random error, right? What is the reason for that? How you can rectify or minimize that error. Okay, correct? Systematic error is a constant error. It is in one direction, either plus or minus, right? This is due to mainly due to the faulty instrument. Then when it comes to random error, what is random error? Random error is variable error. It can go in both direction, either plus or minus, right? So it mainly due to human error, and you can minimize this by taking multiple readings and an average of it, average or mean of it. Okay. From this video, you understood that what is systematic error and what is random error, right? The cause, how to minimize those errors, right? So you have also heard that accurate reading and the reading is very precise. What is next topic is what is accuracy and what is precision. Okay, that we will discuss in the next video. This is Sanal. See you in the next video. Bye.